Martha, Lee, Nancy, Paul, and Armando have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. In how many ways can they arrive? So the order in which they arrive is significant. So this is going to be a permutation. So we have 5 total people, and all 5 of them are arriving to this party. So this is going to be 5p5, which is equal to 120. Now we can solve this the alternate way, which is with the blanks. So there are 5 total people who could arrive first, and then once the first person arrives, there's only 4 people left, and then there's only 3 people left, and then only 2, and then only 1. And we get the same thing, 120. Part B says, in how many ways can they arrive where Martha arrives last? And I think this one is actually easier solving it the way with the blanks. Because if Martha arrives last, then that has to be a 1. And then there's only 4 people left for the first blank. So it will be 4 times 3 times 2 times 1 times 1, which is equal to 24. If you want to solve this using a permutation, you can, but you would have to take Martha out of the equation because it's for certain that she has to arrive last. So we have to take her out of the equation, and you would type 4p4, and that's equal to 24. So I find that it's easier to just solve this way. So part C says, what is the probability that Martha will arrive last? So there's 120 total ways that the 5 people can arrive, and there's 24 ways in which they can arrive where Martha arrives last. So this is 24 over 120, which reduces to 1 over 5.